Everything that you see in deep learning in today's world, like images, text, sound, videos, and even weights of neural networks, they are made of just one thing at its core, and that's called a tensor. The entire PyTorch ecosystem is built around it. The heart, the DNA of every model is this tensor. So the question is, what is this tensor and what are they made of? So tensor is just a container for numbers. It could be 0D tensor, it could be 1D vector, it could be 2D matrix, and beyond that. It's just stack of matrices forming higher dimensional data. You can think of tensors as just NumPy arrays. But now the question is, if they are just NumPy arrays, why do we even need tensors? Or what's the difference between NumPy array and PyTorch tensor in this case? So at first glance, nothing fancy, both holds numerical data, both support slicing, reshaping, broadcasting, viewing, and whatnot. But deep learning isn't just about storing data. It's about running millions or even billions of matrix multiplication at a lightning speed. That's where tensors really shine. When NumPy was created, it was created for the CPU world because there were no talks of GPU or nobody was performing billions of matrix multiplications or computations. It's nothing about the GPU devices, CUDA kernels, or parallel executions. So NumPy was built for the CPU world, single memory space, general purpose cores. PyTorch, on the other hand, is written in C++ and CUDA compilers, meaning each tensors can either live on CPU or GPU memory, and PyTorch or other framework knows exactly how to send those operations to the GPU for acceleration. So when you write tensor.to CUDA, it doesn't just move, it transfers data from system RAM to the GPU VRAM, and where thousands of CUDA threads and CUDA kernels can perform your operations in parallel. And that's what makes training a 10 million parameter or even billion nowadays network even possible. The beauty of PyTorch is that it abstracts all complexity. So the same code works whether you move your tensor to GPU or CPU. So you just move it once and everything else runs as expected and as fast. So that's all about tensors. In the next part, we'll go hands-on creating tensors, reshaping them, and running various operations on them. Because understanding tensors isn't just a theory. It's where deep learning begins and it's the core of deep learning. So once you have that intuition of imagining and understanding tensors, learning and understanding deep learning algorithms will be way easier. So with that, see you in the part 5 of the series.